In this video, we're going to develop what we call a compound angle identity. So again, there's sets. There's a few compound angle identities. So we're going to come up with one in this video. So the way we're going to do this is we'll take 2 points, one with coordinates a1, a2, and the other one b1, b2. Point a1, a2 makes an angle of alpha with the positive x-axis, and b1, b2 makes an angle of beta with the positive x-axis. And they're both on the unit circle. So beta is this angle here, and alpha is this angle here. Okay. Now, what we're going to do is what we mean by compound angle is when you add or subtract two angles. So we want to come up with an identity for the difference of alpha and beta. And we're going to do the cosine identity first, just because that's the easier one to develop. So we want to come up with a rule for cosine of alpha minus beta. And that rule is going to involve cosine and sine of alpha and beta. So what we have to do is, where on this picture is the angle alpha minus beta? Well, that would be this angle in between, right? Because this one's alpha, and then if we subtract beta, we get alpha minus beta. So we're looking at sort of the angle between these two terminal arms. So I'm actually going to turn that into a triangle. So that should be a straight line. So I have this triangle formed by the two terminal arms, and then that red line there. I'm going to call this side C. So what I need to do is come up with a trigonometric equation or formula involving this angle alpha minus beta. Two things to remember here, or I guess more than two things, but we know since a1, a2, and b1, b2 are on the unit circle, we know that cos of alpha is equal to a1, and sine of alpha is equal to a2, and cos of beta equals b1, and sine of beta equals b2. So that will be useful later on. Now what we're going to do is we're going to calculate the length of C. So remember, we have this triangle here. I'm going to calculate this length in two separate ways. So calculate So the first way we're going to do it is using the cosine law. The reason we have to use cosine law is this triangle here is a non-right angle triangle. So in order to calculate the length of a side in a non-right angle triangle, you need cosine law. So remember, cosine law says that c squared equals a squared plus b squared minus 2ab cosine of c, where c is the angle opposite to side c. Well, c, like side c, we'll just use the letter c. So c squared equals a squared. Remember, this was the unit circle, so the terminal arms here are both of magnitude 1. So it's going to be 1 squared plus 1 squared minus 2 times AB, both sides are 1. And then cosine of C, C is the angle in this triangle, so that's the angle alpha minus beta, which is, remember we're trying to come up with an identity for cosine of alpha minus beta, so this is sort of what we're going to be looking for. So just simplify this a little bit. C squared equals, it's going to be 2 minus 2 cosine alpha minus beta. Now if I want to get the magnitude, I take the square root. I'm just going to leave it as c squared, and you'll see why sort of in what we do next. So now we need another way to calculate this magnitude of c. Now remember, c is the distance between these 2 points. So the other way we're going to do it is using the distance formula, which you would have learned in grade 10, distance between 2 points. So using distance formula, or length of a line formula, you might have called it. So the length of a line, so in this case c, is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Now just to get rid of the square root sign so I don't have to write square root every time, I'm just going to square both sides. Now x1, x2, y1, y2, those are just the coordinates of the points. So in this case, that would be a1, a2, and b1, b2. So we're looking at a1 minus a2 squared plus, sorry, it wasn't a2, it would have been a1 minus b1. And then a2 minus b2 squared. So what I'll do right now is I have 2 equations for c squared, so I'm just going to set those equal to each other, right? This equation and this equation should be, they're both equal to c squared. So setting those 2 equations equal to each other, I'm going to have a1 minus b1 squared plus a2 minus b2 squared. So that's this should be equal to this. So now, remember what we're trying to do. We are trying to come up with a formula for cos alpha minus beta, or an identity for cos alpha minus beta. Well, I have my cos alpha minus beta here, so essentially all I'm going to do is solve. However, this is in terms of these points a1, a2, b1, b2. I'm going to make a substitution, and that substitution I'm going to make is this. I'm going to take these values. Remember, I had these values here. I'm just going to substitute these in for a1, a2, b1, b2. So a1 is equal to cos alpha. So I have cos alpha minus b1, that was cos beta. That's all squared. Plus a2, that's sine alpha. Minus sine beta. And then that's equal to 2 minus 2 cos alpha minus beta. Now remember, I'm going to solve for this to try to get an identity for it. But before I do that, I'll just expand this. Because what you're going to see is a lot of this is going to simplify once we expand. So if I expand, I get cos squared alpha, and then 2 cos alpha cos beta plus cos squared beta. That's just expanding this one. If I expand that one, I get sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. And then that's equal to 2 minus 2 cos alpha minus beta. So when you expand it, it doesn't look simpler. But notice here I have cos squared alpha and sine squared alpha. So if you remember, you have the identity cos squared alpha plus sine squared. That's equal to 1. And then I also have cos squared beta and sine squared beta. And again, that's equal to 1. So that identity simplified things a lot. And then I still have the 2 cos alpha cos beta, and then this one here minus 2 sine alpha sine beta, and that's equal to 2 minus 2 cos alpha minus beta. Here I can add these 2's. So 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta equals 2 minus 2 cos alpha minus beta. I have a positive 2 here and a positive 2 here, so I can subtract 2 from both sides, which would leave me with 2 cos alpha cos beta minus 2 sine alpha sine beta. That's equal to negative 2 cos alpha minus beta. Each term has a coefficient of negative 2, so if I divide everything by negative 2, right, and you can do that, divide both sides by negative 2, you are left with cos alpha minus beta on the right side is equal to cos alpha cos beta plus sine alpha sine beta, and here is our identity. Usually I write it in the reverse order. So usually it would be written cos alpha minus beta equals cos alpha cos beta plus sine alpha sine beta. And that's your first compound identity. So this is the cosine compound identity for alpha minus beta. We'll have one for alpha plus beta, as well as ones for sine and tangent.